In the classroom. Just call me sir. Let's get to work now, shall we? What's going to happen in today's episode? Ding! It's math time with Mrs. Morrow! And we are doing intercept form. I'm excited because we've already factored for this Whoa, look at what's going on here. For this moment. Yes, let's do this.
Is set the equation equal to 0. We're then going to split and set each factor group equal to 0. So here's one of the groups. Here's my other group. And then the last part is just to solve for x or whatever variable they give us. So in this case, x is equal to -2. Sometimes they'll ask you to put it in form of an ordered pair. Okay, so now it's your turn. Try number 2. All right, so here we are. Here's my function, and if you notice, the vertex is at -3, -4. The zeros, which is what we practiced earlier, but I hope you could do mental math here. And then it's opening up. All right, so one of the things I didn't focus on was finding that axis of symmetry using the formula that they gave us. And just as a refresher, here it is. And that's p plus q divided by 2. So these are it right there. We're going to divide them by 2. So when we add -5 and a -1, I hope you guys realize that's a -6 divided by 2. So x is equal to a -3 here, which means that's where the axis of symmetry is going to go, right? So, all right, so now, I know that sounds like crazy here, but now that we found that x is equal to 3, again, that's the axis of symmetry, we're going to use this value and we're going to plug this back over here. I know earlier we used it to find the zeros, but now we're going to use this to find the vertex. What's -3 plus 5? And then -3 plus 1 is also a 2, but it's negative. And then when we multiply 2 and a -2, we get a -4. So that means that the y value for the vertex is at -4. So our vertex is at -3 for the x, -4. So if we're just estimating here, it's about down here, something like that. So now we can go ahead and make our sketch. It's not perfect, but there it is. The domain is all real numbers because it's forever going to go left, forever going to go right. The range, though, this is our lowest point. So the vertex happens to be at -3, -4. So that means that y is going to be anything greater than or equal to -4. And I should have labeled my little points over here. This was at -5, 0 for one of my zeros. And the other one is -1, 0. Which is what we have here. The only thing we didn't include was the y-intercept, but other than that, we match pretty well. So, how'd you do? Do you guys remember what two numbers multiplied in -15? So we multiplied a and c and adds up to b. So what multiplies to -15? Can you see it? 5 times a -3. But when you add them, we add up to a 2. And luckily, when we have an a value that's 1, we don't need to divide by anything. So we have our factors as x plus 5 and then x minus 3. We're going to set that equal to 0. So hopefully you can see that our x-intercepts are going to be at x equals a -5 and a +3. All right, and then the axis symmetry is going to be at -1. Going to use that to play. So our y is going to turn out to be 4 times the -4. So the vertex is going to be at -1, 16. So just going to estimate it's going to be somewhere down below. And just so you're aware, this is a vertical intercept, so that would be about here. So it's going to be a graph that looks similar to this. I know it's not perfect, but you can put it in Desmos. You got all of your components here, your vertex, your 2 zeros, your axis of symmetry. I believe we have all of the data and the set of all real numbers for our domain. And y, this is opening up, greater than or equal to the lowest point, which should be negative 16. Hope you guys are catching on. Here we're going to find the zeros of the function. Algebraically, I would just set this equal to 0, and then I would solve for that if I can. So in this case, let's try it out. We're going to add 6, and we get 6 on one side. It's equal to 6x squared. Divide by the 6. We end up with a 1 is equal to x squared. So what's the square root of 1? And because we have an x can be a possibility of a positive and a negative 1. You have two answers here. Go ahead and go to Desmos, graph that in there, and you're going to see that it's going to open up, and your 2 zeros, one's going to be at negative 1, and the other one's going to be at positive 1. Check it out. All right, I'm going to go back to chapter 7 to kind of help remind you guys you can use Desmos, but again, try to remember how to find the function or the zeros of the function by using your factoring skills. So we multiply a and c, which is 20. The two numbers add up to 9. So what are those two numbers that multiply to this? Hopefully you can see it's 4 and 5. And now we can go ahead and preset our factors. Oh, I know I put the 5 there first. Doesn't matter which one you put first. And all of these are equal to 0. So then divide by a, p cubed by a, but a is 1, so you're pretty much done. So remember a little mental math. One of your x-intercepts is going to be at 5, and the other one's going to be at negative 4. Do you guys remember? I hope you do. And then verify in Desmos. A times c goes up here. B goes down here. What two numbers multiply to a negative 10 but add up to a negative 3? I hope you can think of negative 5 and a positive 2. They multiply to this negative 10 and they add up to the negative 3. So if notice the a value is 1, so you don't have to worry about that part. And that means that it's x minus 5, x plus 2. That's equal to 0, which means that the x's are the opposite of what you see. Think about it, because x has to be a 5 to be a 0. So x has to be a 5 to be a 0. And then this x over here has to be a negative 2 to 0 out. So now we can go ahead and graph our points. 1, 2, 3, 5, negative 2. And it's just a sketch. So we can use our knowledge of how to find the axis of symmetry to try to find the vertex. All right, I've gone ahead and drawn a dashed segment here to represent the axis of symmetry. So that means our vertex is going to be somewhere here. So here we're just using PEMDAS, parentheses, but these don't count because that's multiplication. So we have to do exponents first, then you can multiply. So now I'm going to go ahead and subtract. This is just your function notation, so don't freak out about that. Remember, that's semester 1. Okay, so in this case, this is going to be off the chart. So let's just pretend that it's somewhere down here. This is going to become our representation of our vertex. It's just not a very good graph, but it's okay. We'll make it work. So if we could graph that, it's supposed to be a nice smooth curve, but I hope you guys get the idea. We've got our zeros right here at 5, 0, and at negative 2, 0. And we have our axis of symmetry also labeled, but we just needed to make a sketch. This one over here for number 10, it's going to be upside down. We've got a vertical stretch by a factor of 2, and one of my zeros is at negative 3. So here's negative 3, 0, and then 1, 0. We can add them up. So negative 3 plus 1 divided by 2, that's a negative 2 divided by 2. So that means that the axis of symmetry is going to go through x is equal to negative 1. So I'm just going to pretend to make line here. All right, and now I'm going to use my equation to find my y-coordinate from my vertex. So if I substitute in a -1 plus 3 is a +2. Now remember there's a -2 at the beginning. And then -1 minus 1 is a -2. So 2 negatives turn into a positive. There's 3 2's. So that's going to turn into an 8. That means that my vertex is at -1, 8. And again, it's off the charts. Hey, let's make the best of it. So let's just pretend it's somewhere up here. Now notice it's upside down. We can just go ahead and connect. And here's our sketch. 11 is a cubic function, and cubic functions they look like this. So the first thing we need to start off is by factoring the GCF. So what is the greatest common factor? Well, an x might help if I can write x, and then you're left with x squared minus 9. I hope you guys remember this is the difference of perfect squares. So x minus a 3, x plus a 3. When we multiply this out, it turns into this. Notice it has no middle term. I hope you remember. So now we can set all of these equal to 0. So one of our x's or x-intercepts is at 0. One's going to be at a +3. One's going to be at a -3. Okay, so for the sake of just making a sketch, just make it like this because we're just going to take it easy. Here's what it should really look like. But this is more algebra 2, so we're going to stop at this level, okay? So don't overcomplicate it. We're just making a sketch. As long as you can do that, we're fine.
All right, guys. Make sure to try the practice. You gotta try.